All right, so what we want to do right here is we want to actually take a look at exercise 1.10.3. We want to show non-equivalence for expressions with some nested quantifiers. So what we want to do with this is we want to actually understand better what these nested quantifiers mean, all right, and then show how we'd actually show equivalence or non-equivalence utilizing a truth table, all right? So we want to show that they're not logically equivalent by filling out a table so that we have this domain A, B, C, and the values of the predicate P. You select the table that causes one of the statements to be true and the other to be false. Okay? So let's take a look at this. And it can sometimes get a little complicated and you have to do some thinking about it. And it can be a little bit hard. But first, let's make sure that we understand what it is that we're doing. Okay? So first, let's set up a truth table with our domain A, B, and C. Okay? So here's A, B, C, A, B, C. We'll allow the rows to be X's and the columns to be Y's. And this is actually really important, because if you switch the X's and Y's, you can potentially get different truth statements. For example, this statement right here, this is called P of BA. That is because the X value is the B and the Y value is the A. Okay, so we just want to be, make sure that we're cognizant that that's what's happening. In our function, that just means that they're located in different areas. Okay, so let's take a look and let's figure out what these two statements mean, okay, and see if we can kind of think through that and then think through finding some truth values that will make the one true and the other one false. So let's say for all x, there exists a y such that P of xy. Now what this is saying is, for each x, we can find a y. It could be the same value, could be a different one, such that P of xy is true. So it could be a different y for every x value. So each x value might have a different y. That's fine, okay? That's going to be totally okay. On the other hand, we have there exists an x for all y such that P of xy. And so what this is saying is there exists one x, or there exists an x for every y such that P of xy is true. What we notice here is we're going to notice that in this case, this second statement is that this is an individual x. So this is the same x for every y. And that's what that nested quantifier means. Same x for every y. Okay? So what we want to do is we want to make sure that for each one of our x's, we'll get a particular y, okay? But that for all three of our y's, we do not have the same x that'll give us a truth value. So what I'm going to do in order to have that happen is I'm actually going to go through with my y values, all right? And I'll assign, let's say for example, P of AA is true. Okay, so I'm going to make this true. And so when y is a, right, and x is a, we get truth. That's true. Okay, and then what I'll do is I'll assign false for both of these statements. False, false. Okay, great. Now I'm going to take a look and I'm going to go in and I'm now going to, excuse me, that's not what I want. I want truth there. And then I'll select now, let's go to B. And let's say, for example, B, I want it to be C. So I'm going to have P of CB. Okay, C is my X value, B is my Y value, and I want that to be true. So this is going to be true right there. That's true. Okay, my X value is C, my Y value is B. All good. And so now, what I want to make sure that I have, just to make sure that everything is actually kind of works out, let's put this thing here as true. And what that'll be is that'll then be P of BC equals true. So now what I've got is I've got for all of my x's, okay, there is a y, right? A goes along with A, that's a y that makes it true. Good. B goes with C, or excuse me, C goes with B, so that's going to end up being true, so CB, right? And then BC, that also ends up being true. And now all I need to do is I need to make sure that it's not the same x for each of the y's. So if I look here, I have now A A true, okay, so our y has A associated with it, so consequently that's the first one. Now then for B, my y as B, okay, what I end up with is my x value is C. So that actually is different, all right? That's good. That's what we want, okay? And then P of BC, if we notice that for C, B is going to end up being different, okay? For C, B will end up being different. Excuse me, C is now going to have our B be X, or excuse me, our X be B, okay? And so consequently, we actually have 3 different X values for each individual Y. So if I just go in here and I press and I make each and every one of these guys false, then what I actually have now is I now have that this first statement is true and the second statement is false, okay? And let's just kind of demonstrate exactly what it is that we've done here. It's a little tricky to see, but let's hopefully a little wrap up will help us, okay? So I know that P of AA equals true, and P of CB equals true, and P of BC equals true. So for all x, there exists a y, okay, such that P of xy. That's true. We just showed that, right? Every single x, A, B, and C, does have an individual y that will make it true, okay? Now, for the second statement, there exists an x for all y, okay? When it comes to, we'll start with A, right? We have P of AA is true, but P of AB, okay, equals false. So for that y, A doesn't work. So consequently, we're good. Okay, what we know now is that one at least, well, A doesn't work as the value that will work for every single y. Let's try B. We go to B and we see that P of AB, or excuse me, P of BA equals false, right? So that doesn't work, okay? And also P of BB is false, okay? So those are both false. So B actually is incorrect either, because we just have that P of BA doesn't work for A. That's another one. So now let's take a look at C. We take a look at P of CA. That's false. So consequently, C doesn't work for every Y either, right? Notice that what we would have to have for this to be true, for at least for the A's, okay, we would have to have one of the values, right, for X, either A, right, B, or C, okay, be true for all 3 of the statements, okay? And we can actually go in, we'll finish up the last piece here. Let's try P of AC, we know that that's equal to false, okay? We know that P of BC, okay, that'll actually equal true, that's fine. We know that P of CB is true, okay, and we know that P of CC equals false. So when we look here, A, we cannot find, the A's don't work for all 3. Okay, that's the one I want. The A's don't work for all 3. So like in this case, we get that for A, B, and C, right, we can't select A as a choice that will work for all 3 of the Y's. We can't select B that will work for all 3 of the Y's. Okay, so consequently, that's not a choice. So B doesn't work either. Okay, and then we look at C, right, and C, right, we have a false, a true, a false. So C also doesn't work for each one of the Y's, for A, B, and C. So consequently, that tells us that this statement for all X, or there exists an X for all Y, okay, such that P of XY is in fact false. Okay, so what we see is we can find this setting of values here is going to give us true, but when we utilize the same set of values, it makes the other statement false, and that proves that the 2 statements are in fact not equivalent. Okay, so what we want to do, the real challenge here is, well, there's a lot of challenges. One, first, make sure that you understand how the table works. Second, what we want to see is, okay, well, what does it mean to have this statement for all X there exists a Y, and how is that different from there exists an X for all Y? And so consequently, we want to make sure that we understand what each one of those statements mean. Spend most of your time figuring that out. Figuring out what the statements mean, all right? And then from there, you can actually construct the table more easily. Is there a system for constructing the table? Not really, okay? What you have to do is you're going to have to work through the logic. I generally start out with the one that I want to prove is true, okay? And then fill in the rest by with the other parts that I want to prove is false, all right? So hopefully this helps you out with 1.10.3.